40,000 test flights. That number sounds impossible. Not 40, not 400, 40,000. And now headlines are claiming the world's first real flying car is shocking the United States aviation industry. But here's the real question. Is this a true flying car revolution? Or is this a highly controlled test program being presented as mainstream breakthrough? Because building a prototype is one thing. Completing 40,000 test flights is something completely different. Today we are breaking down what 40,000 flights actually means, whether this is truly the first flying car, and why the United States aviation regulators are paying attention. If you want grounded analysis on future mobility, aerospace engineering, and disruptive technology without hype, subscribe to the channel right now. We separate engineering reality from viral exaggeration, because aviation is not forgiving, and flight numbers matter. Let us begin. What do 40,000 test flights actually mean? Let us slow this down immediately, because 40,000 test flights sounds dramatic. But in aviation, numbers require context. Keycap 1. What counts as a test flight? A test flight does not always mean a full cross-country trip, a long-duration passenger flight, a commercial route. It can include short vertical takeoff and landing cycles, controlled hover tests, automated stability checks, low-altitude pattern circuits, repeated battery stress runs. If a prototype performs multiple short flight cycles per day, those numbers accumulate quickly. For example, if a company performs 50 short flights per day, 5 days per week, that equals over 12,000 flights per year. Over several years, 40,000 becomes mathematically realistic. So the number is impressive, but it may reflect controlled test repetition, not mass adoption. Keycap 2. Is this really the first flying car? Now let us define flying car. There are generally 3 categories. Rotable aircraft that drive and then unfold wings to fly. Electric vertical takeoff and landing vehicles, also called eVTOL aircraft. Autonomous urban air mobility platforms. Many companies globally are developing eVTOL aircraft, but very few have accumulated tens of thousands of test cycles. If a company truly completed 40,000 safe flight operations, that signals stability validation, repeated system reliability, battery endurance testing, software control maturity. That moves the project beyond pure concept stage. Keycap 3. The certification barrier. Here is the real bottleneck. Flying cars are not regulated like cars. They fall under aviation authorities. In the United States, that means Federal Aviation Administration approval. Certification requires structural integrity testing, redundant system validation, emergency procedure verification, noise compliance, pilot training standards. 40,000 test flights help build safety data, but certification is not automatic. Aviation moves slowly for a reason. Safety. Keycap 4. Why the US is paying attention. If a flying car platform demonstrates high repetition reliability, strong battery safety, stable autonomous control, acceptable noise levels, then regulators take notice. Because urban air mobility could reduce road congestion, change commuting patterns, create new aviation infrastructure demand, but it also introduces air traffic management complexity, urban safety concerns, insurance challenges. 40,000 flights may signal technical maturity, but regulatory maturity is a separate challenge. Now ask yourself this carefully. Does 40,000 test flights prove the flying car era has arrived? Or does it simply prove that the prototype phase is becoming serious? Before we move into the economics and whether this could ever become affordable for normal consumers, make sure you are subscribed. The next chapter will break down the cost reality behind flying cars. The cost reality. Who can actually afford a flying car? Now we reach the most important part of this entire discussion. Even if 40,000 test flights prove technical stability, who can actually afford this thing? Because engineering success does not automatically equal consumer adoption. Keycap 1. Early flying cars will not be cheap. Let us be realistic. Early-stage flying car, or eVTOL aircraft pricing, is typically expected to land between $200,000, $500,000, sometimes even higher depending on configuration. Why? Because aviation-grade components are expensive. You are paying for redundant propulsion systems, aerospace-grade materials, flight control computers, certified battery systems, aviation safety testing. This is not automotive pricing. This is aerospace pricing. Keycap 2 maintenance is aviation level. Owning a flying vehicle is not like owning a car. Aviation requires routine inspections, certified maintenance technicians, strict part replacement schedules, software validation updates. Even if the vehicle is electric, aviation standards remain strict. Maintenance cost could rival small aircraft ownership. That limits mass market appeal. Keycap 3 the real first market, air taxi services. Here is where things get interesting. The first large-scale use case will likely not be personal ownership. It will be urban air taxi networks, airport shuttle routes, premium commuter services, corporate transport. Instead of individuals buying flying cars, companies may operate fleets. Passengers book rides similar to ride-sharing. This model spreads cost across thousands of trips. That makes pricing more realistic. Keycap 4 infrastructure is the hidden barrier. Flying cars require more than vehicles. They require vertiports, charging stations, air traffic coordination, urban zoning approval. Without infrastructure, adoption stalls. Infrastructure development takes years. That is why 40,000 flights are impressive. But commercialization requires ecosystem build-out. Now pause and think. If flying cars begin as premium air taxi services instead of personal vehicles, does that still count as revolution? Or does it become a niche luxury market? Before we move into the final verdict on whether this is a genuine transportation shift or controlled experimental hype, make sure you are subscribed. The final chapter will answer the big question directly. Is this a real transportation revolution or controlled hype? Now let us answer the headline honestly. 40,000 test flights is not a publicity stunt number. It signals serious engineering effort. It signals repeated system validation. It signals battery durability testing, flight stability improvement, and software refinement. But it does not automatically mean flying cars are about to fill the skies next year. What this actually proves: 40,000 flights prove 3 important things. The vehicle can repeatedly take off and land without catastrophic failure. The control systems are stable enough for continued testing. The battery and propulsion system have survived heavy cycling. That moves the technology out of pure concept stage. It enters pre-commercialization maturity. That is significant. What it does not prove: it does not prove full Federal Aviation Administration certification, nationwide airspace integration, affordable consumer pricing, mass production at scale. Engineering maturity and regulatory maturity move at different speeds. Certification can take years. Infrastructure can take longer. The most likely 2026 scenario. Here is the realistic near-term path. We may see limited commercial air taxi pilots in specific cities, corporate partnerships with airports, premium commuter routes, gradual vertiport development. What we will not see immediately is millions of personal flying cars replacing roads. Aviation evolves carefully, for good reason. Safety is not negotiable. The bigger long-term impact. Even if adoption begins small, the psychological barrier is breaking. For decades, flying cars were science fiction. Now we have electric propulsion, autonomous flight control systems, high repetition testing, urban mobility investment. The shift may not be instant, but it is no longer imaginary. That matters. Now I want your honest perspective. If flying cars become premium air taxi services within the next 5 years, would you try it? Or would you wait until the technology matures further? Comment below and let us discuss. If you value balanced analysis on future mobility, aviation safety, and transportation economics, subscribe and turn on notifications so you do not miss our next deep dive. And in the next video, we will analyze whether electric vertical takeoff aircraft could eventually replace short-haul domestic flights. Thank you for watching. Stay grounded, think long-term, and I will see you in the next one.